It seems obvious that submarines are painted black to hide in the dark ocean, but this is a myth. At a depth of 300 feet, the water is already pitch black, and a black hull is no more hidden than a white one. On the surface, the opposite is true. That cold dark body stands out against the bright water, easy to spot from an aircraft or even a satellite. So if black is bad for hiding from the eye, why is every modern submarine still painted the color of midnight? The answer is that a submarine's deadliest enemy was never the human eye. It is sound. At the height of the Cold War, engineers understood a simple truth. Down in the deep, you cannot see a target, but you can hear it. Enemy ships hunt with sonar, sending pulses of sound into the water and listening for the echo. And the black you see on a submarine is not paint at all. It is a thick skin of special rubber tiles, bonded to the entire steel hull. Hidden inside that rubber are thousands of tiny air pockets of different sizes, and they swallow enemy sound waves whole. In this episode, we go beneath the hull of the stealthiest machines ever built and take apart the secret that makes a billion-dollar sonar fire into empty water. The early 1940s. British anti-submarine ships sweep the water, sending powerful sonic pulses into the depths. The screens should light up with the silhouette of a target. Instead, the signals vanish without a trace. There is only silence in the headphones of the operators, even though a massive steel submarine is moving directly beneath them. In 1944, the submarine U-480, under the command of Hans Joachim Förster, sets out on patrol into waters the British Navy controls completely. Ordinary boats are detected here within minutes. The U-480 does the impossible. She spends weeks near the enemy, almost invisible to the hunters above. Ships pass within a few hundred meters, pinging the water with sound, and they hear nothing. The reports cause alarm at Allied headquarters. Analysts refuse to believe them. Officers whisper that German scientists have built some mystical device that changes the properties of seawater itself. There are rumors of a magnetic field that bends sound around the hull. Intelligence hunts for the blueprints of a fantastic jamming machine. But the truth turns out to be far simpler. The U-480 carried no futuristic device. Her steel body was simply covered in thousands of sheets of thick synthetic rubber. The project had a secret code name, Alberich, after the dwarf from old German legend who owned a cloak of invisibility. The secret was in the structure of the tiles. Engineers built them in 2 layers, with thousands of small holes sealed inside. Some cavities were 4 millimeters across, others only 2. When a sonar pulse struck the skin, it slipped into these pores. The trapped air was instantly compressed, absorbing the energy of the pulse. Sound turned into heat and faded to nothing. The ocean sent its signal, but nothing came back. Yet the technology hit a hard wall almost at once. The adhesive could not survive salt water and the crushing pressure of the deep. Tiles began to peel away in numbers, right in the middle of a patrol. A torn flap of rubber did more than expose the bare hull. It created turbulence in the water, and the boat began to make noise, giving away the very position it was built to hide. German engineers never solved the problem before the war ended. After the surrender, the project was closed, and the samples passed to the Allies. The British studied the captured boat carefully and dismissed the rubber coating as unreliable and not worth pursuing. But Soviet engineers looked at the same drawings and saw the future. 20 years later, in an atmosphere of absolute secrecy, new nuclear giants begin to slip out of Soviet docks, and Western sonar engineers experience a genuine shock. The late 1960s, an American anti-submarine ship is on patrol in the North Atlantic. The sonar operator listens carefully to the voice of the ocean. Suddenly, the clear signal of a Soviet nuclear submarine simply disappears from his screen. Only yesterday, its machinery could be heard for hundreds of kilometers. Today there is nothing but the empty hiss of water. At that moment, a quiet panic begins in Western Naval Headquarters. The Americans realize they have lost track of an entire class of enemy ships. New Soviet boats are leaving the docks sealed inside massive blocks of rubber. NATO records a sharp drop in the detectability of Soviet submarines. In the intelligence services, alarming theories are born overnight. Some analysts claim the Soviets have installed silent jet engines. Newspapers discuss rumors of mysterious force fields that absorb every vibration around the hull. A few experts believe the metal itself has been changed, made somehow soft, but the real reason left them even more uneasy. Soviet scientists had turned the outer hull of a submarine into a giant acoustic black hole. They had created their own hydroacoustic coating. Each tile weighed around 10 kilograms, fixed to the metal with a special compound. And the real genius was that it worked in two directions at once. The rubber not only absorbed the enemy's incoming sonar, it also acted as a thick blanket on the inside, trapping the noise of the submarine's own turbines, pumps, and generators, and keeping that sound from ever leaking out into the sea. But this incredible silence came at a brutal cost. Coatings like these demanded entire factories and teams of specialists, and the ocean attacked them around the clock. Every dive to a depth of hundreds of meters squeezed and flexed the steel. The rubber blocks cracked and the fastenings took monstrous loads. Losing even a few panels could change the boat's unique acoustic fingerprint and make it easier to detect. Commanders demanded that every tile be protected because repairs cost millions. But you cannot stop physics, and you cannot stop salt water. Pieces of the coating came loose on long voyages, again and again. The worst part was where those secret fragments went. They did not sink quietly to the bottom. Powerful ocean currents picked them up and carried them straight toward the shore. Picture a deserted northern beach after a night's storm. A local resident walks along the waterline and notices a strange object in the sand. A heavy, jet-black slab of material covered in perfect round holes. The man picks it up, with no idea that he is holding one of the great secrets of the fleet. Within hours, emergency crews arrive, and the beach is sealed off from curious eyes. Cases like this really do happen. The ocean keeps tearing fragments of acoustic coating from the hulls of submarines. One well-known incident occurred on the northern coast near Severodvinsk, the city where Russia builds its nuclear submarines. Photos of a black, perforated chunk of rubber thrown up by the surf spread across forums and drew intense interest from military analysts. Foreign intelligence agencies quietly hunt for debris exactly like this, because every great power dreams of getting its hands on a piece of a rival's hull. Wild theories grow around such finds on the internet. People mistake the torn tiles for fragments of crashed aircraft or pieces of secret installations. Bloggers claim the rubber on the beach is proof of hidden battles taking place beneath the waves right now, but the real value of the find is greater than any fiction. To an expert, that piece of rubber is a treasure. A laboratory can break down the polymer and work out the exact recipe of the mixture. From the shape of the internal air cells, engineers can estimate which frequencies the coating was built to absorb, and therefore what kind of sonar the enemy feared most. Measuring the density of the material hints at the maximum depth the hull was designed to survive. A single missing tile can reveal part of the secret of a multi-billion-dollar warship. That is why navies spend enormous sums to stop these fragments from leaking out. But when people look at photographs of these secret materials, the same question always returns. Why is this vital layer of protection always pitch black? Almost every viewer is certain the dark color was chosen for perfect camouflage in the blackness of the deep. Reality destroys that idea completely. On a bright, sunny day, a huge missile submarine moves across the open ocean on the surface. Its massive, coal-black hull stands out against the clear blue water and becomes a perfect target for the cameras of reconnaissance satellites. Any observer in orbit can mark its exact position. As pure camouflage, the color looks like a gross mistake. And until the middle of the 20th century, submarines were not always dark. During the Second World War, boats were painted gray, pale green, even white. British submarines in the Mediterranean wore a particular blue-green tone to blend with the seabed in shallow, sunlit water. The old tactic was to hide the silhouette from eyes on the horizon at any cost. Today, the logic has flipped entirely. Popular blogs still claim that the modern black is the result of long optical research, a special paint that hides the boat from searchlights and makes it vanish from the air. But the laws of physics tear these myths apart. Below 100 meters, there is absolute darkness. Sunlight simply cannot reach that deep. In those conditions, any object, whether white or yellow, looks black anyway. So the black of a submarine is not chosen for stealth at all. It is the natural color of carbon black, the soot-like filler added to rubber to give it strength. That carbon is chemically necessary so that the heavy tiles can survive aggressive salt water. The boat became black almost by accident. This recipe simply does the main job best, swallowing the sound pulses of enemy sonar. Engineers did try to change it. In the United States, tests were run on tiles of other shades to camouflage boats in bright coastal water. But adding any color dye made the material worse. The rubber lost its strength, turned brittle in the cold, and stopped absorbing sound. In the end, the fight for silence beat visual camouflage completely, but keeping that protective layer on the hull turned out to be a formidable task. Picture the giant dry dock of a closed military port. The newest nuclear submarine slips slowly into the concrete basin after a long patrol, and pumps work around the clock to drain the water. As the level drops, the engineers on the pier freeze. The hull looks terrifying. It is covered in deep, ragged, bald patches, as if the steel colossus had been gnawed at for months by the creatures of the deep. In recent years, detailed photographs of damaged submarines have leaked into public view and instantly sparked heated debate around the world. Whole rows of heavy black tiles torn away, bare gray metal exposed. A wave of criticism erupts on social media. Bloggers write about shoddy repairs and failed defense contracts. Civilians claim the fleet is falling apart and that secret technology has been lost to engineering mistakes, but experienced specialists just shrug. This same defect is recorded on American, British, and French nuclear boats. It is simply inevitable where, in the dry dock, grueling and precise work begins. Hundreds of workers inspect every square meter of the enormous body by hand. They use special scanners to find hidden air gaps under the tiles that remain. Each damaged section has to be cut away, the steel cleaned to a shine, and a complex adhesive applied that cures under tightly controlled temperature. The work is done under intense secrecy and brutal time pressure. The command pushes the engineers hard, because while the boat sits in the dock, it is completely out of the global game on the ocean. Downtime and materials run into the millions. But the Navy will pay any price, because a submarine with a damaged hull leaves a unique trail in the water. A modern tracking system will not just detect such a boat. Foreign sensors can record the exact pattern of the damage as a digital fingerprint. The boat loses its facelessness. It can be recognized by its own distinct noise. Engineers race to return the hull to perfect smoothness before the enemy's databases learn its new signature forever. And yet this same disguise can create a far more dangerous problem. Imagine a sealed control room deep underwater. The only light comes from the dim glow of the instruments. Sonar operators sit with headphones on, concentrating on every faint rustle. They cannot see the ocean through the thick walls. Colored tracks of sound frequencies crawl across the screens in front of them. At that moment, they are fighting a duel against an invisible enemy. The only way to find a target at depth is to hear its acoustic signature, and here lies the great paradox of modern underwater warfare. In chasing absolute silence, engineers made their own ships dangerous to one another. In 2009, an incident occurred in the Atlantic. A British and a French nuclear submarine were on patrol in the same stretch of ocean. Both carried the latest rubber coatings and the finest sound insulation in the world. And because of that perfect camouflage, the two boats drifted closer and closer and physically collided in the deep. Until the final second, the sonar teams on both sides heard absolutely nothing. Their instruments showed only the empty, natural background of the sea. To prevent disasters like that, and to outsmart enemy sensors, engineers now turn submarines into staggeringly complex systems. Inside the hull, the giant engines are no longer welded directly to the steel frame. They sit on enormous shock-absorbing platforms. Every pipe, every pump is isolated with flexible rubber couplings. Designers build bulkheads where each new barrier holds back a particular frequency of vibration, refusing to let the sound break through to the outer hull. The race for the perfect acoustic signature only grows more intense. Secret chemistry labs work around the clock to create smart polymers, materials that can change their density on the move, at depth, in response to the surrounding water. Engineers dream of an artificial skin for ships, one that copies the structure of a dolphin's body and smooths away every turbulence in the flow. Experimental samples are already being tested at closed sites. And right now, somewhere, another black submarine is sliding silently into the dark ocean, ready to rewrite the rules of underwater war.